Hello, my name is Rob Reynolds, and I'm going to introduce College Algebra Section 1.5. We're talking today about inequalities. Inequalities are similar to equations, but instead of having equal signs, we have greater than or less than signs or less than or equal to signs. Remember, less than points to the left is the easiest way that you can remember this. Less than points to the left, and you can make those little less than signs from that. So if you have a less than sign, you can write the word less, and if you have a less than sign, you can write the word left. This yellow is pronounced x is greater than or equal to 2. All the values of x that are greater than or equal to 2. Normally, in Algebra 2, you'd put a solid green dot here and then shade everything to the right. In pre-calculus and calculus, we start using these brackets. If we include the point, if it's a closed dot, I'll bracket it like this in red. If it's an open dot, I'll use a parentheses. This symbol is pronounced infinity. The sideways 8 is the infinity symbol, and we can never reach infinity. So that means I want all the values that are up to infinity, but since I can't reach it, we'll treat it like an open dot. This 2 means I have a closed dot at 2. If it was an open dot at 2, and the function looked like this, and I want all the values that are greater than or equal to 2, then I would say the interval from 2 to infinity, again, I can't reach infinity, and here I would want everything up to 2, but not including the 2. So for closed intervals, it means I'm using a bracket. For open intervals, it means I'm using parentheses. It just means I can't include those values of a and b. That's what an open interval is. I can have half open and half closed intervals. That just means one side is a closed dot, the other side is an open dot. And remember, for infinity, I can never reach positive infinity. I can never reach a negative infinity, so you never put a bracket on the infinity sign. Here's all the different forms that you could use with parentheses or brackets. So trying, I'm going to start with inequality notation. This is called inequality, and we're going to change it to interval notation. And interval notation is using either the parentheses or the brackets. So under here, I would say, I want to include the values of 2 and 4, so I would put brackets on both of those. For this next problem, I would say, I don't want to include 2, I don't want to include 7, but I just want to include all the values up next to it, so I would use parentheses. This has read all the values of x that are greater than or equal to 6. To write that, I would start at 6 and go all the way to the right to positive infinity. So again, I'm putting a bracket because this is an equal sign. So I bracket the 6. Again, I'm just showing you the difference between, this is Algebra 2, inequality notation, and then this is called, everything over on this side is called interval notation. So for the last one, you guessed it, I'm going to go to negative infinity all the way up to 3. You always go from the left to the right on your intervals. So always move left to right. Never give me the right and then move left. So let's go the opposite direction. If I give you interval notation, can you translate that back into inequality notation? So this says all the values between -1 and 2. So you would say, x is between all those values of -1 and 2. And to write a between statement, you put, again, the lower number on the left, and you use less than signs. So here it is. X is sandwiched in between. -1 is the lower, up to 2. Notice that I have an open, not equal to sign, open dot on the left, and since this is a bracket, I will close, which means it's all the values are equal up to and including 2. So for this one, it's another between statement. I want all the values of x that are between -2 and 0, and it looks like I can include both, so use those equal signs on both sides. For this one, I want all the values between 5 and infinity, but you don't really say between 5 and infinity. You just say all the values of x that are greater than. It can't be equal to 5 because of the parentheses. Whoops. So we just say, hey, because of this parentheses, I just want all the values of x that are greater than 5. So there it is, all the values of x that are greater than 5. And the last one, can you think about what the answer would be? you guessed it, all the values of x that are less than 1. So remember, every time that you square, even if it's a -2, every time you square it, it becomes a positive. Be careful to type this into your calculator, because if you type in -2 squared, you'll actually get a -4, and so your calculator is sometimes hard. If you forget to use the parentheses, you'll get wrong answers. This is saying, hey, you can add c to both sides for inequalities, and it stays true. You can subtract, you can multiply. So if I add 5 to both sides, it's still true. If this is the original statement, x is less than -5, I can add 5 to both sides, and it still remains a true inequality. I could subtract 2 from both sides, and again, the inequality remains the same. What this is talking about here is if you multiply both sides by 2, then we still end up with a good inequality, and I can show that to you. If I multiply both sides, we know, we know that 3 is less than 7. That's a good inequality. But if I multiply both sides by 2, we also know that 6 is still less than 14. That still remains true. So I'm showing you can add both sides, you can subtract both sides, you can multiply both sides. Just be careful. If you multiply both sides by a negative, then something interesting happens. Let's start with that 3 is less than 7 again. But if I multiply this time by a -2, watch what happens. I get -6 over on this side, and on this side I get -14, and this time I need to flip the inequality sign. The less than sign goes to a greater than sign, because -6 on a thermostat is actually higher than -14. So if I think about 0 degrees being here, -6 is a higher temperature. It's a greater temperature than -14. So remember, if a value is less than, then you can multiply by c and keep the sign the same. But if a is less than b, and you multiply by a negative, then notice that that less than sign is going to flip to greater. That's what this slide is talking about. So again, we need to get to some examples here, but if you divide both sides by 2, we're not going to flip the sign. Notice this sign less than stays less than. But if you divide by -3, or multiply both sides by -3, you better flip the sign from greater to less than. The reciprocal property says that if 5 is greater than 0, then the reciprocal of 5, which is 1/5, will still be greater than 0. So solving some inequalities, let's look at some examples. Again, we can combine like terms. Even though this looks like a grouping mechanism, there's nothing wrong with adding the 2 and the 6 and ending up with 8. And then remember, you can add 5 to both sides or divide both sides by 4. The only thing you want to watch out for is to multiply both sides by a negative or divide both sides by negative. That's when you need to flip the inequality sign. I would prefer you not write the answers 3 is less than x. I prefer x is greater than 3. Down here, if you divide both sides by -2, remember you're divided by a negative, so we're going to have to flip that inequality sign from greater to less than -3. All right, so here we go. To solve your first example, we're going to undo the addition by subtracting off the 3. Next, I'm going to divide both sides by -2, remembering the property if I divide by a negative, I flip the inequality sign, which, oops, I just forgot to do, so I'll change that back to x is greater than -1. I'm going to put an open dot at -1, but instead of doing an open dot, I think I would prefer to use interval notation, which I think MyMathLab would prefer. So using an open dot, and I want all the values that are greater than. So instead of using an open dot, I'm using parentheses and brackets, So I'm going to use a parentheses there. So let's, the final solution would be all the values of -1 up to infinity. And I can't include the -1, and I cannot include infinity. So the final answer, I hope you can recognize the answer in both forms. This one is the form in the inequality form, and this one is an interval notation. And I'm trying to get you to feel more and more comfortable with interval notation here. So for this one, I'd probably like to get all of the x's on the same side. So again, my recommendation is get rid of the smaller x. So I'm going to subtract off 2x from both sides. So I'm left with 2x plus 7 is greater than or equal to -3. Next, I'll subtract off 7. and get a negative 10. And dividing by 2, remember I'm not dividing by a negative, even though the 10 is negative, I'm not dividing by a negative, so I do not flip the inequality sign. X is greater than or equal to negative 5. This time I put a closed dot, but instead of closing the dot, I'm going to try to do the bracket notation. And again, I want everything that's greater than, so I would write negative 5, everything up to infinity. I can't include infinity, and I put a bracket on the negative 5. And the author agrees. It's a good solution. So, combining a couple inequalities. This is called a compound statement where I've got two inequalities. I would go ahead and add 2 to both sides. So I'm adding 2 to this side and adding 2 to this side for a total of negative 3 is less than 3x, which is less than 3. The next thing I would do is divide every term by 3. So I'm going to divide the right side by 3 and divide with the left side by 3. Again, not flipping any signs because I'm not dividing by a negative. So I get negative 1 is less than x, which is less than 1, which is just a between statement. I want all the values between negative 1 and 1. So I'm shading everything in here. To write this, I would say negative 1 up to 1. So again, there's interval notation. And again, the author's solution. For this one, I would probably try to multiply every term by 2, just so that I can cancel and get rid of these fractions right here. So over on this side, I am left with negative 2 is less than or equal to 3 minus 5x, which is less than or equal to 18. My next step is probably to subtract off this 3. So I'm left with negative 5 is less than or equal to negative 5x, which is less than or equal to 15. My final step is to divide through by negative 5. So remember, when you divide through by a negative, you flip those inequality signs. So in this case, we're left with 1. And if I flip the sign is greater than or equal to x, which is greater than or equal to, this is negative 3. But this is kind of funny because I don't have the lower number on the left. So I might want to reorganize this and put the lower number on the left. So negative 3 and 1, and I want my x's between, and I'm going to put, again, the lower number on the left, and I'm going to use less than signs. So I want all the values between negative 3 and 1, and I'm going to use brackets because I can include those. So I'll say negative 3 with a bracket for interval notation all the way up to 1. And again, here's how the author writes the final solution. For this one, this is the reciprocal function, so I'm going to say 1 over 4x minus 1 is greater than 0. The idea for this problem is to look for critical values that either come from the numerator or the denominator. If the problem said x plus 3 over x minus 2, a critical value would be anything that sets the numerator or denominator equal to 0. So up here, a critical value would be negative 3, and down here, a critical value would be 2, and I'd place those on a number line. Well, for this problem that we're working on, our only critical value comes from the denominator, and that is setting this equal to 0. So the only critical value here is when x equals 1/4. So I'm going to test this on a number line. I'll place 1/4 on a number line, and I'm going to try values to the right of 1/4, and I'll try values to the left of 1/4 to find out if this inequality is true or false. So let's try in a f at 1. So if I try at 1, I get 4 times 1, which is 4, and 4 minus 1 is 1/3, and 1/3 is positive, and that as long as this is positive, I know it's greater than 0. So everything over here seems to be true. Let me just check to make sure that this is false over here. So we'll try f of 0, which is to the left of my critical value, 1/4. But if I plug in a 0 here, I get 4 times 0 minus 1, which is greater than 0. And this is going to be a false statement because this is not true. Negative 1 is not greater than 0. So I know everything over to the left is false. So and I'm going to use a bracket because it's not equal to it. So everything that's greater than 1/4 is my solution. And again, the author agrees. I would probably write this as what? 1/4 to infinity, and I can't include the infinity. The idea for this problem is to change this x into a 2x plus 1. And you can do that by multiplying by 2 and then adding 1. Same thing for this problem. We're changing x into 3x plus 2. So start with the original and multiply everything through by 3. Next, we're going to add everything through by 2, and a will equal negative 7, b will equal 8.